Hello, everyone, and welcome to this month's Newcastle Discover, the latest in our Discover series. I'm Lily Moore, Alumni Engagement Manager here at Newcastle University, and I'll be your host for today's event. As always, a massive thank you to everyone who is joining us. If you've been to one of our events before, or if it's your first time here, welcome. We're glad to be with you for the next hour. The Newcastle Discover series is brought to you by our Newcastle University's alumni engagement team and aims to encourage lifelong learning through thought-provoking and insightful events on the latest in university research and practical life skills sessions. It's great to be back with you all and see some new faces, hopefully. Our Newcastle Discover programme for this year is aligned to our NCL in Action theme, exploring AI's impact on our world. This is our year-long programme of events, volunteering opportunities, and other activities that are designed to help you explore the way in which AI and future technologies could potentially change our lives and the way that we work. In the Discover events, expect to dive into universities' cutting-edge research in AI technology, and across disciplines and industries, as well as how AI tools and tech can support us in our everyday lives. So, moving on to the content of today's event, the future of AI is on the edge. AI algorithms have become an inevitable part of our lives and are so pervasive that users often engage with them unconsciously. Both users and systems contribute vast amounts of data to train these algorithms. AI addresses a wide range of critical and sensitive problems, from medical diagnostics and climate change mitigation to assisted driving and financial technologies. However, AI systems do come with their advantages and drawbacks. One significant concern is the security of our AI systems. Are they vulnerable to sophisticated malicious attacks, unintentional changes, omissions of context in training data, sensor aging, and so on? This makes AI applications at the edge, such as smartphones and cars, susceptible to defects in training data and AI models. Edge AI focuses on safeguarding data integrity and the quality of the learning associated with AI algorithms when they are exposed to cyber attacks in edge computing environments, such as those in the EPSRC National Edge Artificial Intelligence Hub. Today, we are delighted to be joined by Dr. Varun Ojha, who is a senior lecturer, associate professor in AI at the School of Computing at Newcastle University. He is an artificial intelligence theme leader and co-I on the EPSRC-funded National Edge AI Hub. He works in artificial intelligence, deep learning, neural networks, machine learning, and data science. A huge welcome, Varun, to you today. And without further ado, I'm going to hand over to you.
Thank you, Lily, for introduction. So welcome, everyone. So today we are going to discuss about future of AI is on the edge. So we put this title, The Future of AI is on the Edge. As Lily mentioned, that we have a hub, AI hub in the Newcastle. We call it National Edge AI Hub. It's a large funded project. So I'm one of the AI team leader on this hub. And obviously, I'm working as an associate professor in artificial intelligence in the School of Computing in the Newcastle University. So what is our National Edge AI Hub? It's a large consortium of universities across the UK. So it's basically universities across the spectrum of the entire UK. So Newcastle University is the lead of this project. Is a large 12 million investment from the EPSRC, so UKRI Research Funding Agency, which has funded this project. And we are leading this project on the topic of Edge AI. So I will be going through the description of what we are doing in this hub. So before that, I want to basically run through some kind of introductory aspect of AI. So artificial intelligence in general, what we perceive, most of people out there knows about AI pretty much. They have understanding of what AI is and what AI is doing. So we generally, as a scientist, categorize AI into two dimensions. One is called general purpose AI, and another one is a special purpose AI. So general purpose AI is the concept what we have in our mind that AI is like a science fiction movie. It's like Matrix is one of the early very interesting example of general purpose AI. or Ex Machina is one of the movie from the Britain, is another example of an AI algorithm working very efficiently, a human-like approach. So that is what the general purpose AI is trying to replicating the human brain. We are many scientists believe that we are not there yet, and the special purpose AI is the day-to-day life AI algorithms, so which is like recognition of cats and dogs, in the medical domain, recognizing the X-ray images and so on. So these are the special purpose AI that the AI algorithms are built for doing certain tasks. Now, this emergence of ChatGPT, which revolutionized the concept of AI to the much larger spectrum of the audience than it was before. Then we have simultaneously there are several different algorithms like Grok, Gemini, and Runway, DALI-E. There are so many generative AI, which is another term we use these days. So the question is now becoming like this ChatGPT like models, which has basically scared the audience about the power of AI. The question is whether they are towards the general purpose AI. Are they solving general purpose AI problems? So, or they are closer to the special purpose AI. So these are the debates still running in the scientific audience as well as in the general public. So with this emergence of like revolution of AI, we are coming to kind of a concept like the power of AI. As you can see in this video, this is AI algorithm generated video, and it's completely feels like it's a movie, like somebody has created a movie, and the actors are real actors. So generative AI is becoming very, very powerful. So this is an algorithm called Sora. Then we have another algorithm, another type of video. So you see this the the power of generative AI. It's kind of highly realistic. So this gives us kind of this revolution of AI is more towards the close to the general public. They are more engaged with AI these days. Another generative AI, as you can see here, is you give a prompt to the generative AI. So you have a text called a dolphin in an astronaut suit on the Saturn. It's basically creating the imaginary things what we have in our mind. And then here is another image where you give some prompt, it writes some text, and it can generate an image what you want to see, like a propaganda poster for the cat, like in the French emperor's suit. So basically, the meaning is that generative AI is becoming, or the AI is becoming very, very powerful to solve different kinds of problem or provide solution to the real world problems. This brings us to the something called AI arms race. So the large research funding agencies and in the governments, they are funding large amount of money to kind of win this AI race, because those who are considered to hold the AI, another term is like the AI is the new oil. So the government agencies, research agencies are funding a large amount of money to the to kind of uplift their capability, research and innovation capability for AI. So you can see that this recent phenomena called DeepSeek has basically shaken the whole AI market. There's already large US-based companies who are producing very powerful AI models. So like XAI from the Grok is another ChatGPT kind of algorithms, and so on and so on. So the meaning is that AI is basically going to govern a large part of our lives. And what's happening is the models of the AI models, they are keep bigger and bigger. And you can see that the ChatGPT 1 to ChatGPT 4, we have burned about 63 million pounds for just training a ChatGPT model. And the model size, training data size is becoming larger and larger. So in this, we don't have data for ChatGPT 4, but ChatGPT 3, you can see 1 petabyte. It's extremely large amount of data and extremely large amount of money. And the training time to build these models. So at one hand, we have a huge benefit, we use public oriented benefits of AI, and the other hand is that we are burning large amount of money and computing resources. So what happened with this emergence of large language models and on the large scale of AI is that the compute energy demand of our lives is keep increasing higher and higher. As you can see in this chart, that the compute energy demand close to about 2040 is projected to reach the total world's energy production demand. So it's basically the energy consumptions by this the large AI model is giving us a kind of a thought that should be how we proceed in the future to safeguard this energy problem. And there are some other associated problem with this the AI arms race. In another spectrum, you can see that the all data centers in the world is consuming more electricity than this country itself. Like Italy, you can see the energy consumption by Italy is much lower than the all data centers in the world. So the data centers are consuming huge amount of electricity, and basically this gives us what are the solutions we can proceed for solving this kind of one problem. So I'm approaching this talk today is through the energy consumption problem, but there are huge spectrum of problems with AI that we can deal with. So one of the approach we consider that moving from cloud AI is this all generative AI is a cloud AI. Basically, they are running on a big data center, because running a chat GPT is not possible to run on the simple computers. Big, large data centers are running those algorithms. So moving from cloud AI based applications or a cloud AI based kind of development of AI, we move to the edge AI. Edge AI is like moving the AI algorithm close to the devices we have. They have this moving to cloud to edge AI has several problems, several challenges. So for example, how to simplify the models, how to reduce the power consumption, how we can quantize the model to run them on edge devices, how we can perform the training on the edge devices, and federated learning. So these are the potential approaches how we can solve this problem. So edge AI, why edge AI? So in the contrast to the cloud AI, which is like ChatGPT, Runway, and all these algorithms are running on the data centers, we have the possibility of running AI algorithms on the smartphones, cameras, medical devices, and so on. So that's basically becomes edge AI. The benefit is that it will ensure a fast or very speedy inference, and because also these models will be running close to the data source, like where the data is produced. Data is generally produced at the devices, so there will be a reduced latency, reduced cost, reduced power consumptions. And moreover, the important aspect is if we run the AI algorithms on the edge, it will protect our data privacy, it will reduce the risk of cybersecurity, and so on. So there are large number of benefits to run AI algorithms on the edge, but this is not so simple to run the AI algorithms on the edge. There is lots of complexity that we are trying to solve in this National Edge AI Hub. So one example here is reducing the risk of inference failure in the critical systems of the edge AI. So this is an interesting example I can give in autonomous vehicle and the healthcare. So imagine somebody is doing surgery and they're relying on the internet for internet basically to run the AI algorithm from the cloud. And the internet bandwidth is a big factor of saving lives, because we know how internet works. The bandwidth of internet works in places. Sometimes you can't reach the internet. So relying on the cloud AI for critical systems is highly dangerous, especially in the critical systems like autonomous vehicle and healthcare, where the people's life is directly on the line. So these are the benefits of running AI on the edge. Another aspect is that these days we have a running supercomputer in our pockets. So for example, this is a quotation, this is the specification from iPhone 16, which is the latest iPhone. You can see the power of this edge device. So phone is an edge device, and you can see it has a 6-core CPU. My first computer was a Pentium 4 Intel CPU. It has a single core. And it has a 5-core GPU and 16-core neural engine. So neural engine is basically AI engine. 512 gigabyte of memory and so many sensors, like a 48 megapixel camera. Most of you remember the floppy disk is only 4.8 megabyte is the size, and now even the simple camera, one picture is 48 megapixel. So the power of devices has increased thanks to the Moore's law, and we have reached to kind of a place where we can run this effectively these AI models on the edge devices. So that's basically bringing the industrial revolution of something called edge AI revolution. And we can see that the industrial spectrum, where we have the industrial IoT, healthcare systems, surveillance, autonomous vehicle, drones, smart factory, these are all have devices that can run AI algorithm, or we can build AI algorithms to run on these edge devices to benefit this large spectrum of industry. And that's why you can see the Gartner in 2023 projected that the next big thing is basically edge AI or edge computer vision. So these are the kind of emerging dimensions of revolution in AI. So that's our National Edge AI Hub is focusing on various spectrum of how we can facilitate edge AI on the large space of the application domain, as well as we will perform the fundamental research. The another spectrum of, because of the emergence of this edge AI, now the generative AI algorithms, these big algorithms, we just see some examples, they are moving to the edge. So this is a kind of a diagram which shows that what edge AI actually means for life. So we have the sensors and actuators in the factory, or in whatever the sensors we have in the phone. Around us, there is a large number of sensors. So these are the IoT sensors. And if we push our AI computation close to that sensors, that is basically edge AI. And you can see on the right hand most side, we have the data centers, which is the cloud AI. So if AI algorithm is running close to the sensors where the data is produced, that is basically we are doing the edge AI. And if we are processing like a deep learning AI training and so on the cloud, that is we are doing the cloud AI, or this generative AI is running on the cloud on data centers. So our objective is to move the processing of or training and inference of AI close to the source of the data. This trend is very much kind of around the world now. You can see that the exponential growth of large language models like ChatGPT is GPT-4 in terms of model size. The billions of parameters of the model size has reached to close to about 2023, and now it's kind of a new field where we are kind of moving towards something called small large language models, or small language models, where we are trying to quantize the models. We are trying to reduce the size of the models so that it can run on the edge, or at least even it can run on a simple computer, because running a large language model on a computer is still not feasible. There are some models like a llama and so on, you can run them on the computer. So the trend is to reduce the model size and try to run them on the edge devices. That bring us basically how we can how this AI is basically an emergent field, what we can think about it. So for example, here is the we as a consumer of the AI is actually also the producer of the AI these days. So we are the data producer. We feed the data to the AI models. Like we know that we have the Facebook as the first emerging, where we are posting our pictures, our text, our story. In the Google, all the time we are posting, or we are feeding our data to the Google. And the models, the models which is in the cloud or in the data center of the Google, they are learning from our data. So that is the traditional model of how this powerful AI algorithms have been built over the time. Now the emergent field is that we are also the AI model producer. So what we do is that this is called federated learning concept, where our devices, like our smartphone, has some app, and we produce our data, and our data stay at our computer, our phone, and the models, AI applications, they are trained on our model itself. Only the weights and biases of those models goes to the central server to make a powerful AI algorithms. So the federation of learning is kind of benefiting us with the data privacy and so on, and as well as helping us to run the models on the edge itself. So the fast inference, all the benefits of edge AI we achieving through this kind of concept of federated or distributed learning. So in the National Edge AI Hub, in fact, in my own research, we are working a lot on this kind of concept. So surrounding this Edge AI concept for the Edge AI Hub, we have AI theme challenges, which I'm leading. So the AI theme challenges comes with a different kind of perspective. Once we federate this concept of data and training AI model on the edge, we have problem with the data quality. And as well, we have problem with the model quality, because once we have the model running on the edge systems, the models are vulnerable to several kind of problems like adversarial attack, the model weight corruption, and so on and so on. And the data quality problem is obvious, that somebody can feed a poor data to the model, so the model will learn poor data. So federating this AI to the general public for training and distribution of model learning is at one hand, it's a very beneficial as the promise is about the inference, promise about the data privacy, and promise about for the critical system not relying on internet and so on. But this also brings a lot of challenges of data quality when it's running on the edge computing environment. So we are setting around scientific critical problems, challenges that we want to solve in this Edge AI Hub. And once we are deploying AI algorithm on the wild in the edge, we have several other aspects to consider: the edge computing environment itself, the cybersecurity aspect, the applications we are trying, the sensitivity of the application we are trying to run the AI algorithm for. So in Edge AI Hub, we are dealing with this all the work streams. So WS here means work streams. So we are trying to deal with that, and they are all interactive kind of models. So AI theme challenges for developing a next generation Edge AI algorithm. We are trying to interact with all these possible challenges. So in Newcastle University, we actually have a test bed, which we can basically test our algorithms, or we can develop for kind of do the research and innovation task. So this is one example where Edge AI example where the camera is looking at the street, and you can monitor the number of cars, speed of the movement of the car, pedestrian, and so on. So it can basically do a lot of visual analytics on the fly. And this helps in so many things. On the real-time management of this simple example is helpful in many spectrums, like a traffic management, emergency response, or safety of the road users in this case. These are all aspects that can be a real-world problem solved by this Edge AI. The problem is, once you deploy, like for example, here is counting number of cars. Once you deploy this algorithm on the edge, there is a problem with the data quality, as I mentioned. For example, here is the environmental sensors are deployed here, and the environmental sensors are prone to degradation. So once the AI algorithms the sensors are degraded, the data quality feeding to the AI algorithm will be degraded. There is a very interesting term people use in AI is called garbage in, garbage out. So we need to be monitoring the AI algorithm's performance for its efficacy, for its robustness, and for its trustworthiness, and so on and so on. So data quality is the prime factor when that can reduce the trust or reduce the robustness of AI algorithm deployed in real world. So there's lots of problems with data quality, as I mentioned before as well. So the data distribution problem. So there could be unknown examples which coming into data to AI algorithm. Cyber attack is another problem. the denial of the services, like somebody intentionally do a cyber attack and block the access of AI algorithm to data. Hardware failure. So hardware failure could give us anomalous input to the AI algorithm, and we might be still believing the AI algorithm is working well. So there is a huge amount of challenges when we deal with edge AI. The adversarial attack example here is an interesting example where you can have autonomous vehicle riding on the road, and then you have a pedestrian and some adversary, whether could be a cyber attack or somebody put a patch on the speed limit sign, and the car is misclassifying a pedestrian to a speed limit change. So you might think that from 20-mile run to 40-mile or so on. So instead of braking, car might speed up, and basically it's endangering the pedestrian's life. So these are the challenges we have with the model quality. So how to trust, how to make the AI algorithms robust enough to withstood this kind of data quality problem. These are the big challenges which the edge AI algorithms, algorithm should be robust enough to. So, and National Edge AI, we are trying to deal with all these problems. The application of edge AI is as I mentioned, to a large spectrum of industry. It's quite relevant for edge AI. So in this example, we worked on the AI algorithms like deep learning, image segmentation, and object detection. So as you can see in this example, we are working on how we can monitor the water, the rise of water. So once you monitor effectively with the automated monitoring with the camera, which is looking at this river, and you can monitor the rise of evolution of water. So this could create a warning mechanism to warn the people living close by the river, or people who want to go for recreational activity to the river. So you can warn them that the water level is rising, and so they could plan their activity accordingly. So, and these models are highly effective. We tested this algorithm onto a flooding event, and they are highly accurate, about 90-95% accurate models. So they are automatically deployed to solve real world problems. Another problem could be in the structural engineering. Here is a bridge, kind of tiny replica of a steel bridge, and we can deploy AI algorithm to monitor this infrastructure. So this collapsing of the steel bridge can be predicted with how much load it can take, and how AI algorithm can simulate and predict the breaking point of the steel bridge. So the infrastructure monitoring, we are doing a lot of work on say, for example, concrete crack monitoring and so on. So the AI algorithm can monitor the infrastructure for the safety of the users of those infrastructure. In the manufacturing environment, AI algorithms can do some revolution. For example, you deploy a camera and you can detect the defects in the factories. You deploy a camera, it can monitor the activity of the human being. So not only what they are doing, we can have the safety aspect of those employee can be done by the automatic camera detection. So your employees in the manufacturing factory are safe, or their operations they are doing is safe. Or even in the beneficial term, if you think economic term, we can monitor the quality of the produce, or quality of the product generated by the people or by the robots itself. So we can have a zero defect, zero waste, and that will reduce reduce loss of problems for the manufacturing industry. However, this kind of models cannot be just standalone, and it has to be in the ecosystem. So if you are doing some kind of human activity recognition, you need to think about the privacy, data privacy, and so on. You need to think about the cyber security. So if your AI algorithm working on the edge, you want to protect your employee, you want to protect your economy and system. So you have to deploy some kind of cyber security system, which is obviously we are dealing with an AI-based cybersecurity systems to protect your model and protect your AI algorithms. So and you can have a effective learning over the time when the experience you are gaining from your model. In the medical domain, AI is a long talked discussion about the radiologist. So the AI algorithms are now basically very effectively detecting disease in the scans. So we have CT scan, ultrasound scan, and so many other types of scan. So you deploy AI algorithms, they can actually assist the doctors. That is the better term we can use. So they can assist the doctor in terms of diagnostic of disease. So they can help, at least they can recommend that these are the things. And then when it to cut down false positive, the doctors can see the explanation or can see the output produced by AI algorithms, so they can deeply investigate the disease detection and so on. So AI algorithm is helping a lot in this dimension. For example, in this case, the multi-organ detection by AI algorithms. So the AI algorithms from a CT scan or MRI scan can easily detect all the organs, and within the organs, if there are disease, there is a tumor, and so on and so on. So AI algorithms are becoming powerful in terms of doing such kind of detection. In fact, recently I read an article where it says that AI alone is better than AI plus doctor. So the AI algorithms are getting powerful enough to do lots of diagnostics itself, automatic diagnostics. And as I mentioned, if it's a critical stuff like a healthcare, edge AI is better when you are doing this kind of model inference, prediction, and so on the edge itself, on the medical device itself. The challenges with the medical domain is because it's still with the healthcare well-being of the patients, how this robustness or the safety concern of AI can be mitigated. So for example, here is I'm only demonstrating the problem with AI is that, let's say you have original image and there is another second row is for modified images. As a human, and now we cannot recognize what is the difference between these two images. So you can see that both images are pretty much same. So a doctor would be effectively doing some kind of a diagnostics based on whatever the images doctor will receive. But for AI algorithm, you can see that the efficacy or effectiveness has reduced quite significantly, dropped from 86% to the performance 44%. So how to know that when AI algorithm is accurate, when it's not accurate, is a big challenge. And we want to improve the robustness of AI algorithm to an extent that we trust very well. This helps. This AI algorithms is helping a lot in the diagnosis. So safety is a concern, and the spectrum of AI kind of going to revolutionize this all stuff is, for example, in this diagram, the AI algorithm can help a remote monitoring of a patient and so on. But these things they cannot stay in a kind of in a silo. So you cannot just have an AI algorithm running on and just doing some performance detection and producing a report for the doctor. But the issue with the AI is like reliability, explainability, transparency, the law, privacy, and so on and so on. So Newcastle University, as you know, has a 3 faculty: computing, medical, science. So the AI is not only a topic of only computer geeks who produce some source the code and let AI algorithm run, but in a surrounding ecosystem, there is a large part of large number of concerns which we need to mitigate. Plus, there are technical concerns like the secure data communication, real-time processing, the performance, or how AI algorithm interact with different sensor, how AI algorithm improve itself. These are all concerns. So you might have heard this new term these days or something called next big wave in AI is called agentic AI. So the agentic AI concept is that these complex AI systems, like what you see on the screen, they the promise of AI scientists or developers is to let the AI act autonomously to reduce the cost, reduce the reliance on so many factors. So the thing with the AI algorithm to learn, adopt, and change to the different situations. So as mentioned before, there are problems like data quality. So how AI algorithm can interact with those kind of problems and so on is a big challenge. And so looking at an AI algorithm with this holistic perspective is called agentic AI, and that is going to be kind of a next big thing. And AI, the National Edge AI Hub is kind of a closer to answering many of those questions as we do lots of fundamental research in Edge AI. And also the UK itself is developing its national has developed its national AI strategy. It is funding a lots of projects in different dimensions of AI. So UK Research and Innovation um, councils or EPSRC Council, AI safety institutes, and so on. There are different aspects of AI that is funded by UK government or UK research innovation councils to further this revolution of AI, or basically, as you can see in the AI arms race, UK is at the rank fourth. So basically, we like to see UK to be number one. So these fundings and this national AI strategy is helping towards that. In the National Edge AI Hub, coming back to what we do in the Newcastle, is that we are focusing on AI data quality, AI model quality, edge computing for AI, and cybersecurity. These are the 4 dimensions of fundamental research we are doing in National Edge AI Hub. So we are the lead, but we are interacting with the universities across the UK. And we are focusing on 4 dimensions of applications: manufacturing, energy, healthcare, and smart transport. So we are looking at the 4 dimensions of applications and 4 fundamental research in our National AI Hub. And if you are a student or if you want to pursue to help us with the research, you can study PhD. You can, if you are industry or want to work with us, so you can explore the different pathways we have created, how the interested people in Edge AI Hub can interact with us or engage with us. So please have a look onto these web pages, or please feel free to send me some emails so we can get in touch. Okay, so with that, I will open for questions. So thank you very much.
Thank you so much, Varun. As Varun just said, we're opening for questions now. So if we've got a couple in the Q&A at the minute, so I'll go through those first, but please use the chat or Q&A function to ask anything you might like. But first of all, Varun, thank you for a really insightful presentation. It's really interesting to hear all of the vast sort of applications that AI is having across different sectors. And I wondered, just as a starting point, where you feel currently AI is maybe having the biggest impact in sort of real world applications, and where maybe it might take us in the future.
Sorry, say it again.
Sure. I'm just wondering in terms of where AI is having where AI is being applied currently. So some of the examples that you gave, like where do you feel it's having the most impact kind of today?
Yeah, so if we consider only for in terms of UK, so if you see the spectrum of the startups and the industries, they are utilizing AI for the special purpose tasks. So there are many companies, even I work with, say, one example I can give is they are monitoring the energy efficiency of your household. So the AI algorithms can help monitor this kind of thing. In the large impact cases, you can see NHS is the big body or big problem where AI is contributing a lot in the healthcare sector. If I can pinpoint specific examples, I mentioned some of them, like in the CT scan and the diagnostics of the in the healthcare with the detecting disease from the images. So these are the specific examples, but in the broader scale, we can say that in the healthcare, AI is making a lot of impact, and a lot of funding from the UK actually goes on in the healthcare. It's like Alzheimer's disease is still an unsolved problem, and a lot of funding, not only UK, in the worldwide, is a huge amount of funding goes there. So the medical domain is a big space for impact of AI, and it can really solve the problem. We know NHS is crumbled with staff and so on and so on. So the AI in the future is going to help a lot with this kind of space. On the crude space, manufacturing is there, automation in industry, and so on. So the impact of AI is quite broad.
Amazing, thank you. I'm going to come to one of the questions that we've had in the Q&A. This is quite a technical question, so I'm hoping that you'll be able to answer, Varun, being definitely more technical expertise than I am. So it's from Sataro. They've said, thank you for the presentation. They have a question about marketing environment of edge AI processors on Copilot Windows PCs. As well known, competition of CPU and NPU manufacturing vendors have not been covered, and edge AI processors are not standardized yet. Software applications have compatibility problems. If possible, would you have information about when and which vendor could win a de facto standard of edge AI processors?
The question is interesting. So one of the challenges for the AI actually is pointed out in this question is this software stack for running AI algorithms on the edge is not a standardized, definitely. It's a big challenge. So what we are doing is largely in the edge AI space is that we are training our own algorithms, and we are, say, for example, FPGA and other hardware. We use them and we deploy our algorithms there. And we try to have a special software for doing a special task. But in the market space, it has not been standardized yet. There's lots of hardware there where we can run, like NVIDIA Jetson Nano and so on is there. We can run AI algorithm. But I agree that it's not standardized, and there is a lack of pervasive use of edge AI, and that's lacking because of the software deployment, compatibility issues, and so on. So these are the problems we need to solve in the future for a broad and huge impact of edge AI. Yeah, I agree with the question.
Great. So we've had a few more questions come in the Q&A. We've had one from Charles. So Charles currently works in an AI startup, and they are an AI-based product offering. And he says, we're finding that a number of clients are very fearful of having an AI device in their facilities or within their network. There's a bit of a fear factor still associated with AI for some people. And have you got any advice or tips for combating this?
Yeah, it's another interesting question, and we are basically, that's why we are doing this research on the analysis and development of algorithms for the robustness of AI working in the application domain. So I agree with this question that the fear of the people and the skepticism for AI is real, and we need to mitigate those things. That's why we have this large funding from UK government about AI Safety Institute. So we are coming to those, actually we are moving towards that direction, so that this skepticism and the fear of people using AI in the real world should be minimized or at least addressed well. So that's why we have the terms like responsible AI and so on.
Yeah, definitely. And I suppose it's a lot about sort of learning and building your knowledge in sort of what AI is and what it can do. It's sort of definitely, I mean, for me, having started this program, I didn't know a lot about AI. Now I feel like I know a lot. And it's definitely taken away some of the sort of maybe fears I might have had about, AI and what it could potentially look like in the future. So yeah, thank you. We've had a question from Ilesh, who's asked, what impact do you envisage in the, he's put in brackets primary, but education sector in terms of how AI might impact education?
So I think his question is for ChatGPT. Yeah, after ChatGPT came in, the whole education sector in the UK is basically discussing about how we can actually work with ChatGPT rather than thinking in terms of whether it has a positive or negative impact. I would say, in my opinion, we need to embrace this new technology like ChatGPT. Because we are going to use it. It's not going to go away. So it has, for the education sector, the students are using ChatGPT to basically answer all our questions. So this is a aspect where the student kind of need to use this technology to solve their problem, and there's nothing harm in my opinion. We as a lecturer or as an educator, we try to see how we can actually use ChatGPT in our coursework, in our education, as a tool rather than saying, okay, you don't use ChatGPT and so on. We design a coursework where student actually can use ChatGPT to solve the problems. It's like a helping tool. If they don't use ChatGPT, they will Google search and so on. So it's still the same things. So I don't see any problem there.
Amazing, thank you. We've had a question from Phil Davies who's asked, should we be worried about developing solutions with AI if distillation is so easy? Is any intellectual property safe? For example, DeepSeek trained on ChatGPT.
So can you say the question again?
Sure. Should we be worried about developing solutions with AI if distillation is so easy? Is any intellectual property safe?
Oh. So I'm not sure about intellectual property, but I can answer the first part of the question. So is it safe to use the distillation, or I think we use in my term or my research, we call it transfer learning. So we have this foundation model is there, and for this special purpose application, we need to, because we cannot train a large model with the images. So we use these large models. We solve our own specific problems. So we distill the knowledge from the large models to a small to our applications. The question of intellectual property, these are all the questions where is a debate, like generative AI uses a lots of content from people who has already produced the content. So these are the questions, as I mentioned, there's a space of AI, of social sciences, where you have the ethics and all this kind of stuff. I'm unfortunately only expert in the technical aspect, not on the peripheral aspect of AI. So this is a problem, but people are solving it, I must say.
Thank you. Had a question around sort of how much time does it take to integrate these edge AI algorithms into existing systems for organizations? So, for example, a car manufacturing client in their assembly line. So, like thinking about the examples that you gave in your presentation, sort of how long did it take to sort of integrate those into existing systems?
So the devices are already capable. That's why I put an example that current devices we have, the evolution of Moore's law, you can see that this small device like USB stick is far powerful these days than a floppy disk just 10 years ago or 15 years ago. So the devices, electronic devices we have, they are capable of running, at least they are very sufficient to run many AI inference. So it's only question of how motivated you are to deploy those algorithms on the edge. And many in manufacturing industry already have this algorithms, so they're already there. So it's a question of your policy, your question of your intent to deploy them. It could a time scale it can vary, depend on all these questions, but it's feasible, I would say, even today.
Thank you. We've had a question around sort of data quality and potential bias, and kind of how are we, I guess, Newcastle, addressing data quality and potential bias in any historical data?
So bias comes from different forms, from the gender bias to all these typical questions of bias. The AI algorithms these days, they try to balance the data sets when they're training. So these are all questions on the responsible AI questions, where we try to make sure that AI algorithms are trained on data that is quality data and is free from this aspect of bias, privacy, and all this, satisfy all these responsible AI questions. So the training of AI algorithm or curation of the data is in this question is the task of people to make sure that we are free from our own bias, so that we can curate the data which is not biased enough. for training. But if we train with the algorithm which has a biased data, it will learn bias, and you cannot stop it easily.
Okay, great. Thank you. We've got one more question, and then I think we'll bring things to a close, if that's okay with you. It's really just to, I guess, elaborate. You touched on sort of work that's happening in Newcastle around sort of data privacy issues, and I just wonder if you can expand on that a little bit. We've had a question about what is Newcastle doing to combat cyber and data privacy issues directly. What safeguards are we putting in place whilst we develop these sorts of models that you've talked about?
Yeah, so these are the core questions in National Edge AI Hub we are tackling in. So federated learning is one example. The data privacy is a key concern. So the promise of federated learning is that the users have their data to themselves. So your phone contains your data. It doesn't go to the shared with any other client or any other people. It's with you, and only the AI algorithm is trained on your device, and only the weights and biases which are encrypted and goes to the server. So the security concern, cyber security concern, and data privacy concerns are mitigated in this kind of distributed federated learning environment. And we are doing a lot of research in National Edge AI Hub. If you are interested, you can have much deeper discussion with us later on. But we are doing actually, this is the core question for us in National Edge AI Hub.
Amazing. Thank you so much. I'm going to bring questions to a close there. I just want to say, Varun, thank you so much for your talk today. It's been super interesting. Special shout out to you, Varun, is joining us from all the way from Philadelphia today. So joining us very early in the morning his time. So massively appreciate it amongst jet lag, I imagine. So a huge thank you. Thank you to everyone who's been with us on the call today. I've seen lots of comments in the chat from staff members, from alumni, graduating across many years. So lovely to see you all. Hope you've all enjoyed this afternoon's event. Varun's slides and the recording of this video will be shared in an email with everyone here and who registered post-event. So do look out for that coming into your inbox. Next up in our Discover series, we have some more webinars and activities coming your way as part of our NCL Action Programme. So firstly, our next webinar is Tech Tips Making Your Mobile Work for You. So I will be joined by Head Engineer at Hedgehog Lab, Becca Anderton, to explore how mobile technology and accessibility features are revolutionising user experiences for everyone and how your device can make your life easier. So anyone wanting to come to that, bring along your smartphone, either Android or iPhone or anything that you've got, and for some practical advice on how to best coordinate and utilise your apps and settings to help you in your everyday life. We also have other sessions coming up. If you are interested in what Varun was saying about medical applications in AI, we have an event on how some Newcastle research and a project about AI preventing bowel cancer. So do join us either in person on campus if you're based in the Northeast, or online for that one at the start of April. A massive thank you to everyone who's been with us. If you want to find out more about our alumni community here at Newcastle, you can get in touch with us at any point or visit our website. I'd like to finish by saying a massive, huge thank you to Varun again, and to everybody else. Enjoy the rest of your day, and I look forward to seeing you all at an event soon.
Thank you. Bye-bye.